Alright, so good morning, good evening, good afternoon, and welcome. So what we're going to focus on today is lesson 8.7 about factoring special products, okay? So we're going to be looking at some tricks, some weird trinomials, and even binomials that are going to be presented to you guys today. And so the factoring that we're going to be doing is a little different than what we had learned on 8.6 with the X method and the A and the C. So if you guys please make sure if you have your books, please open to 539. I have notes on Canvas. Notes are also in my classroom if you need them. But if you have them on Canvas, please know. Big thing is the factoring here. Why is knowing square roots of numbers important for factoring? Because we're about ready to deal with a bunch of them. 4 more topics, 8 total to do. Homework is located on ALEKS, okay? Please make sure you guys get it done. I did have a couple students, don't want to name names, in 6th hour, ladies Paisley and Miss Runyon, where they were asking, hey, I do everything up to the last minute. Okay, you shouldn't do that, but if you do, just know that it's there for you guys right now. All right, I think it is Eastern Standard Time, just to let you guys know, so everything will be closed on Monday around 9:59 p.m. Okay, so what we have is factoring, okay? This is our bell work. I'm not going to go over it. We did this already before. We're going to be using a lot of mathematical practices, looking for structure, looking for repeats, okay? We're going to be doing a lot of modeling and making sense of problems. And then we're going to use the structure of an expression to rewrite a couple things, okay? So a big key thing is that we've been factoring trinomials with two binomials, okay? So we've been factoring them out, and we've been looking at a tri, which is 3 terms, right? Which is x squared plus bx, and then the c. And we make them into two binomials, all right? Where the x plus or x minus. Now we're going to look at different binomials that are difference of squares and some that are even perfect squares, okay? So in your book or on your notes, starting on page 539, it has this key concept where if you see one term that's a perfect square minus another term of a perfect square, you can actually take the square root and make it x plus 5. So example here, x squared minus 25. Square root of this. You can actually take the square root of x squared and you get x, because there are 2 x's in there. Square root of 25 is 5. And so, ladies and gentlemen, you break it down like that, okay? So let's begin, and this is what I mean. So what you're doing is you're factoring out, we're doing it in reverse, okay? So we have to ask ourselves first, is one of these a difference of squares? You would write yes or no, and then if so, you would factor. So what you need to ask yourself is, first off, does it have the negative sign? Okay, yes it does. Second off, can you take the square root of this? So if I can take the square root of m squared and you can come up with a number, then it is a perfect square. So remember what a square root means, okay? Square root would be m times m, especially if it's this. So what it is you have 2 numbers multiplying by each other. So my perfect example is, what is the square root of 9? Well, most of you know that it is equals 3. But what is the breakdown of 9? Breakdown of 9 is actually 3 times 3, which equals 3. So that's the main principle and setup. So if we know that m squared is this setup right here, we know that the answer here is going to be square root is m, and then square root of 64 is in fact what? 8. So we got m plus 8, m minus 8. That's it, okay? It's can you do a square root? If you can, what is the answer? Simple as that, okay? Now, if you wanted to test your theory out, you could to make sure you were doing it correctly. And I'm only going to do this once, m and 8 and m minus 8, right? So if you multiply these out, you get m squared, 8m minus 8m minus 64. 8 minus 8 does what? Cancels each other out. M squared minus 64. Isn't that what I got? It sure is, so I did it correctly. Square root of 16, y squared, would be what? 4y. Square root of this would be plus 9z. 4y minus 9z. Simple, okay? Please don't look at this and say, well, I can't do that. Yeah, you can factor it, okay? Look and see if it's a perfect square. If you can take the square root of it, and it would simplify, please do. So, square root of 9 is 3. Square root of b to the 4. So how many b's are there? There are in fact 4. Okay, that would be a perfect example. It would be 2 times 2 times 2. This is actually 16, right? Square root of 16. if you were to do a square root of this, if these two are the same thing, what is the answer? Get rid of this. They're both what? 4. So that would be the same here. So it would be b squared, and it's going to be plus 5. And then the other term is 3b squared minus 5 because it's square root of 25. Pretty simple, pretty quick, pretty fast. Give me a yes or no, and answer it, please. Alright, longer break than usual, apologize. I need to get a piece of gum. Alright, so here's the question I have for you guys. Number 1, is that a factor? Yes or no? Okay, can you rewrite it? Or do you have to? No, you don't. Square root. 9 and C are possible. Simple. This one here, can you take the square root of this? Well, yeah, you can. 6n. Square root of that, the answer would be what? You can't take the square root of 27. So this is a no. Okay, you can't do that one. It's not real. This one here, square root of 25y squared would be 5y. What, ladies and gentlemen, would be the square root of 1? Well, you don't actually have the square root of 1. It doesn't exist. That's a no. And actually, let me rephrase that. Square root of 5y, this would be 5y, and the square root of this would actually be 1, because I apologize, square root of 1 is actually 1. But here's the problem. Plus sign. What does it need to be? It needs to be negative. So this is a no, because of the sign. Okay, that's why. This one here, square root. 64 would be 8g, that would be h. So ladies and gentlemen, you can, in fact, factor that out. Okay, so that would be easy perfect square. Now we're going to talk about factoring perfect square trinomials. Okay. On these trinomials, this is going to be starting on page 540. You're going to be asking yourself some questions as we go along. Okay, so you're going to see a square like this, and I'm going to ask you: is this a perfect square, and is this a perfect square? Now, here's my only issue with this, is as we go through this caveat together, ladies and gentlemen, if this method is confusing to you, please feel free at any time to go back to the method that I've taught you with the A and the C and the B, okay? If we're going through this and you have no idea what we're doing, please go back to this trinomial method, and let me explain. So on here, can you actually do the ABC squared method? Yeah, you can, okay? Because you don't have anything funky out here. But we're looking for a perfect square trinomial, all right? So you have to ask yourself, can you take a perfect square of this first term? So can you do 25x squared? Yes. The first term of a perfect square is actually what? 5x. Is the last term a perfect square? Well, the answer is what? It's actually yes. It's a 3. So then what you have to see is, according to your formula right here, there's a what? There's a little 2 in there. So the question is can you have a, which is 5x, times 3, which is right here, and a 2 in front? Does this equal the middle term? Okay, so you have to ask yourself that question. So 2 times 5 is 10, times 3 is what? It is in fact 30. Does this sign in the front, does it matter? No, it does not. Okay, you just know right away then that what it does tell you though is, since it's a negative, it tells you that it's going to be a minus b squared. So my answer here is going to be a minus b squared. Right? That's my answer. Okay? Hopefully you guys understand that. Now, like I said before, can we solve it doing this method? Yes, we can. Right? So 25 times 9 is 225, I believe. Okay, and then this would be negative 30. So what two numbers would multiply together? Oh, this is fantastic, right? To make 225, and when you get to 30. So if you didn't know this off the top of your head, you could ask yourself, what would they be? For me, as I look at it, I think the answer is going to be, and I had it on the tip of my tongue, 20, or it's not 25. What two numbers would multiply, and you know it's adding together. So I'm looking at this again. Well, I know it would be 5 and 3. Hold on, let me do the division. I have 3 over 5. And it's going to be, so I do know as you guys go through this, you would figure it out. Grab a calculator if you need to. Go through the whole process. I don't have time to do it. You could do it, technically speaking, okay? I'm trying to think. I know 15 and I know 20 is not going to be a good number. 15 would be 2, 3, 4, 5. That's not a good number. So you just would have to figure it out and go from there. But could you do it? Yes, you could, okay? And then you would do your fraction setup like we worked on before. But for this example here, I want to show you this, okay? So same thing, okay? On this, is this a perfect square? So what is the perfect square? It's 7y. Is the last square perfect term? A perfect square? It is. It's a 6. So then it asks, if you multiply all these together, do you get the middle term? Well, what would be 2 times 7? That would in fact be 14, okay? 14y times 6. Is that going to equal 42? There's no way. So ladies and gentlemen, is this a perfect square? No, it is not. So you cannot probably factor it at this point, okay? So that's what you're shooting for. So please look at these, okay? Remember, you're squaring the first term. It's going to take the square root of the first, square root of the second. Then you're going to multiply it by 2, and you're going to see if it matches the middle. Square root and square root, multiply it, see if it matches the middle. Okay. If I were to do this one, it would be 3y. Okay, so let me write it right here, 3y. And then this term here is going to be 4. So the question then is if I multiply all these together. 2 times 3 is 6, times 4 is 24y. It is a perfect square. So my answer is 3y plus 4 squared. Okay, it's just a trick. Once again, one of the many tricks. So on here, square root of 2a squared. Can you do that? The answer is what? No, because you can't take the square root of 2. Okay, you can take the square root of 2. Sure, we can talk about it, but since you can't do that, that would be a no right away. Okay. All right. Next, factoring out methods. There are multiple methods that you guys can use, but the first thing you have to do, you have to follow these steps. Okay. Sometimes I dislike how when we teach this material, we're not teaching you in the proper steps, where the first thing you look for is the greatest common factor. Okay, like on this example here, do they all share something in common? Well, yeah, they all do. They all share an x, and they all share a number 2, because they're all even. You would factor them out, and then you get your trinomial that you could work with. That's similar to when we did the distribution method. And then check for difference of squares. So if you factor it out, can you take a difference of squares? Okay, if you can, then you would stop and do the difference of squares. The last piece of the puzzle would be factoring by either the binomials that we did or by what we worked on lesson 8.5, which all of you hated, which was by factoring. This bad boy right here, okay? Most of you struggled. Remember, you just put brackets around it and you factored numbers out to get the back end the exact same. All right, if you struggled with that, still, then we need to talk. So those are the 3 steps. So let's look at this step 1. All right, first thing here, can I factor anything out? All right, is there a greatest common factor here? I'm pretty sure there is, ladies and gentlemen. I'm pretty sure they share a 6. So if I take my calculator, 96 divided by 6, I'm going to get 16. So if I factor out a 6, I'm left with x squared minus 16. Look what I have here. Second step then is to what? Check for a difference of squares or a perfect square. Can you take the square root of this one? The answer would be what? Yes, you can. It would be x. Can you take the square root of that? You sure can. It's 4. So ladies and gentlemen, your equation is going to be that right there, perfect square. Okay, so it's a combination of everything we're learning. Any common denominators or common factors in here? The answer would be no. Okay, because this would be 2 and 4. I can pull a 2 or a 4 out of here, but I can't pull that out of there. I can't factor anything out, so we got to let it sit where it's at. So, ladies and gentlemen, now you ask yourself, perfect squares. Yes, that'd be 4y. No, there's no square of 15. So now we got to solve it old school way. Okay, so let's see, hopefully there is a factor for it. So 16 times 15 would be 240. Okay, no, it's a negative number. And if it's negative and positive, then I know I'm going to have a plus and a minus here, and it's 8. So what numbers would go in? So my problem is sometimes with doing this, so 24 would be 24 and 10. It's close, but not really. Let me see here. What other numbers would go into 24? So what I want you guys to do is I'm going to work on my calculator here, see if I can figure it out. So it'd be 20 and 12. And ooh, I got it. Okay, so that's amazing how I keep doing that. 20 times 12 is in fact 240. So if I have it here, this is 20, that's a 12, there's my setup, right? So now you would have your equation. So I'm glad it's not a prime number. So it would be x plus 20, and I'm going to do the A method where I'm factoring. So I'm going to do this, and then it's 16x minus 12. Okay, remember, if you don't like this method, you can use the A where it would be divided by 16 and then solve, but I'm going to go from here. So the question is what can be factored out? I can factor out, from this point here, I can factor out a 4. So if I factor out a 4, I would get 4x plus 5. I don't think I can factor that down anymore. And on this one, if you did a 4, you'd get 4x minus 3. The key term, ladies and gentlemen, then would be these first two. 4 times 4 is in fact 16. Now I realize I wrote an x and it should be a y, but ladies and gentlemen, bear with me on that. Sometimes when I'm on a roll like this, I won't stop and change the variables. I just use what's always comes natural to me, which is x, okay? It should be a y, so if you want to change your final answer to that, just know why you did it up here too, okay? Don't freak out and say, why did I change the variable? Just know what you're doing. All right, this last one here, you'd have to ask yourself, is there a perfect square? No. Can you factor anything out? Well, I do know I can factor a 2 out of here. So if I do a 2, okay, it was going to be 9x to the 4th plus 12. So I know that's plus 12. All right, that's going to be 12. Whoops. Come on now. Go. Pen's going crazy. All right, hold on. Get my pen back. All right, so what it is, I know this is going to be 12x squared, and then this is going to be, of course, plus 4, right? Just like that. So now let's see if the perfect square works, right? So let's see if that would work. That'd be cool if it did. So can you take the square root? Let me change color to red. Square root of this, all right? Because remember, the first thing was factor. Second one was see if you can find the greatest common factor. Square root of that would be 3x squared. And then the square root of 4 is actually what? 2. So if I were to put a 2 there, 2 times 2 is 4, times that would be 12x squared. Bam, we have a perfect match. So it'd be 2, and then it's going to be 3x squared plus 2, and then that is squared. All right? So that, ladies and gentlemen, goes off of what we learned here, okay? Perfect squares. If it is a perfect square, that's the setup, okay? So we know, since it's a perfect square here, that would be there, okay? You multiply it together, you get the middle piece. Ladies and gentlemen, that's your actual answer, okay? So please make sure there are multiple ways of doing it that you check. Greatest common factor, complete the square, and then, of course, the last piece of the puzzle. So please look at this, see if you can factor anything out first, and then go from there. All right, on these ones here, these share a 2, so I can factor out a 2. It'd be x squared minus 16, and then I know that these are a perfect square, so this is going to be 2x minus, or x plus 4, and x minus 4. Does that part matter? No, I'm just kind of picky where to put the pluses first sometimes. On this one here, can you factor anything out? Nope. All right, you can factor out a 5 here, but not out of here. So let's see if it works. So I got 25. Go back to calculate. I got 25 times 12. Okay, that's going to equal 300. So negative 300 here. And then I have to ask myself, when you subtract the numbers, because I have a negative, can you get a positive 5? Okay, so if I have 300 here, knowing, so let's go, if I go 100, that's 30, 60, let me see if I can do this or not. This is going to be challenging, right? So if I go 30, that's 10. If I go 300, wait, I'm thinking 600. What am I doing? 300 divided by 6 is 50, so that's not even close. 300 divided by 10 is 30, so that's not even close. 300 divided by, let's say, 12, that's 25, so I'm getting closer. 300 divided by 15 is 20. Ooh, found it. So it is 20 and 15. So which one needs to be positive? This one, 15. So sometimes, like I've told you guys before, you're going to have to do what? You're going to have to do some math, okay? So figure it out. So I will use the the slide method on this one, bottoms up, sorry, x minus 15. And so I'm going to divide by 12, right? So divide by 12, divide by 12. Okay, so now this one here, you got to reduce the fractions. So can you factor out a 2 from here? Yeah, if you factor out a 2, you'd get what? 10 and 12. So you can do a 4 as well. So factor out a 4. If I did a 4, it'd be 5 and 3. So it'd be x plus 5 over 3. Hopefully you guys understood that you can factor, or if you reduce this equation here can be reduced to 5 over 3. Sorry, I keep yelling factor. And then the other one is going to be reduced to 3 over 4. Okay, so you can take out a 3. If I reduce this, 15 over 12 would be 5 over 4. Sorry, my brain is fried. Been a long day. So 5 and 4. So now what you do is you do what? Remember we talked about before? Bottoms up. Okay? You've simplified it as best as possible. So now your answer is going to be 3x plus 5, 4x minus 5, and that's it. So check your answer. Negative and a positive is going to be negative 25. 3 and 4 is 12. So I know I'm on the right track. If you want to take the rest of the time and look at it, you can. But know that that is the solution setup. Okay. Last piece of the puzzle here is where we're going to apply more than one technique, where you're going to do things multiple times. So for example, if I look at this as a perfect square, can I take the square root of this and this? You can. Okay, square root, of y to the 4th would be y squared. Okay, and then that would be minus the square root of 625. It would be, make sure I get it right, square root of 625 is in fact 25, right? Now that is 25 squared. Now the question is can I take the pieces inside of here? Can I do it again? The answer would be what? Yes, you could. Okay, you can take the square root of this inside. So the trick is not to stop just with the top. So square root of y would be y minus 5. But then what does that mean? Well, that means there's 2 of them here. And if there are 2 already down, that means your exponents are going to be what? 4. So your final answer is going to be y minus 5 to the 4th power. Which makes sense. If I were to actually do the multiplication on this, it'd be y to the 4th. And then if you did 5 to the power of 4, you'd actually get 625. So the same philosophy is going to go here, okay? First off, we're going to do the square root. So square root of 256 is in fact 16. Okay, so if I took the square root of this and this, I get 16 minus n squared. And remember that's got a 2 on the outside. I can take the square root of this again. So if you take the square root of this again, you know you would get 4 minus n. So ladies and gentlemen, now you have your setup. On this one here, it's not just 2, it's 2 times 2. So it'll be 4 minus n to the what power? 4. And there's your setup, okay? So know when you guys set that up, if I were to multiply that out, you guys would be able to get the same answer, okay? So try on these. There's a couple tricky ones in here. Remember, factor first. See if you can factor first. And if you can, factor them, and then answer them out from there. All right, first and foremost on this one, I can factor out a 2. So if I do factor out a 2, I'd be left with y to the 4th minus 25, right? Now, the question is can you take a square root of this? Sure you can. Okay, square root of that would be y squared, and this would be plus 5. Can you go any farther than that? No, you cannot. But know that you did factor this one first, so there's your answer, okay? On this one here, same setup, okay? If I did 6, so if I factored out 6, 96 divided by 6 is in fact 16. It's going to be the same boat, okay? Where when I do it, it's going to be x to the 4th minus 16. It's the same as we had, oh, well, that's different. This is 25. So it's the same setup. Can you square root it again? Yes, you can, okay? If you take the square root again, all right, you guys would be able to know that square root of x to the 4th would in fact be x squared. And then it's going to be minus 4 or plus x squared minus 4. And there's your setup right there, okay? Just remember those things. And then on this one here, most of you maybe not have caught this. This is the beautiful factoring. So please make sure when you guys do this that you use all the options. So can you factor anything out? You can. You can do an m squared. If you do that, then you're left behind with 2m, and it's going to be plus 1, right? So there's your setup here. If I factored out a negative 25, negative 25, what's left behind? A letter 2m here, and that would be plus 1. So now we have our setup where, remember on factoring, that some of you did struggle with. You put those two pieces together, be m squared minus 25, 2m plus 1. Ladies and gentlemen, you are finished. Okay? The last but certainly not least, okay, your setup is right with the negative on the back end. Square root of this would be 4y squared minus 1, and then that is, of course, this would be squared. Then the question then becomes, can you do it again? All right, let me make sure I'm on the right path on these. Then the question then becomes, can you square it on that one? Did I mess that up? Oh, look at that. I'm going to come back to this, by the way. I'm like looking at that and it kind of freaked me out. All right, so on this one now, it's 4y minus 1. So now you ask yourself, can you do anything else with this? Well, you can actually do this square one more time. Okay, and then when you do this square, it's going to be set up as, if you take this on the inside, can you square the inside? The answer, of course, would be yes, you can. So if you take one of them, you would have to leave one behind. Okay, but you can take one of these. If I presented this to you like this, the question is can you square this one by itself? And you could. So you leave one behind, and you simplify this out to be 2y plus 1, and then it would be 2y minus 1. Okay, and that would be your simple setup on this. Now, that's a weird answer to this, but please know that that's the setup for it. And then what I'll do is I'll go back through, and I may have to make a modification to this lesson because I think I made a slight error on some of them. So my question then I have for you guys is this: is this a perfect square? And the answer to this is actually it is. Okay, so that's the struggle on this. Since this is a perfect square, this actually would be m plus 5, and then it's going to be m minus 5. And then do you do anything with this? Nope, it is not. Okay, that would be the setup on there. So one thing as we're going forward, just please know that as we set these up, if I have made a mistake, okay, I will make sure to tell you guys in class. We'll have a good discussion about it. I may have made a mistake on one or two, I'm not sure, and if I did, I'll make sure not to mark those wrong. But know on these last two, they're kind of crazy. Know that you can do things more than once. Okay, we really won't be tested too much on this, but I want to give you guys this aptitude to be able to answer these if presented to you. Okay, so if you have any questions for me, please ask. But in the meantime, good luck. This is the last lesson for chapter 8, and then we are going to be moving on to our test next week, and then we'll be moving on to chapter 9 relatively quickly. And before you know it, we'll be done with the book, and then we'll start some activities up and possibly some financial stuff in my class. In the meantime, ladies and gentlemen, it's been great teaching you. If you have any questions, come see me. Good luck.